Hello everyone, myself Dr. Tarkeshwari Verma from CSVTO. In previous lecture, we discussed about drift motion, drift current, drift velocity and mobility of the electrons. There we studied in detail of the movement of the electron, production of drift current. Due to this current, we got the drift current velocity. Today, we are discussing about diffusion current and its application in different fields. The content of the lecture is key point about the diffusion current. Second one is the definition and types of the diffusion current. Third is the equation of diffusion current. Fourth is diffusion current in PN diode. Next one is the diffusion current in PNP transistor. Let's start our main topic, diffusion current. Diffusion current is the concept primarily used in a field of the physics and electronics, especially in semiconductor physics and solid-state electronics. It refers to the flow of charge carriers such as the electron or a hole within the material due to their natural tendency to move from region of higher concentration to region of lower concentration. Diffusion current is the one of the two main components of the electronic circuit, being drift current. Here are some key points about diffusion current. First is the concentration gradient. Diffusion current arises from movement of the charge carriers in response to a concentration gradient. In other words, we can say the tends to move from areas where they are more concentrated to areas where they are less concentrated. Second one is the direction. Direction of the diffusion current is the always from a region of higher carrier concentration to a region of the lower carrier concentration. For the example, in a semiconductor, electron will be diffused from an area with a high electron concentration to an area of lower electron concentration. Third one is the causes. Diffusion currents is the mainly caused by the thermal motion. As a carrier moves randomly due to thermal energy, you can also understand it is a like Brownian motion. They tends to the migrate toward the region of lower concentration. Equation. The diffusion current density, it's denoted by JD, can be mathematically described by the first law of diffusion. Jt is equal to minus d into del n. This is the product of the d and lambda n, where Jd is the diffusion current density, capital D is the diffusion coefficient of the charge carriers, and n is the represent the concentration gradient of the charge carriers. is the role in a semiconductor? In a semiconductor, diffusion current plays a crucial role in the operation of diodes and transistors. For the example, in a p-n junction diode, electrons and hole diffusion across the junction leads to the formation of a depletion region, which is the fundamental to the diode's rectifying behavior. Sixth one is the opposite of the drift current. Diffusion current is the distinct from the drift current. That means that is the opposite current of the drift current. Drift current refers to the motion of the charge carriers under the influence of the electric field. In contrast, diffusion current is the driven by the concentration gradient with no external electric field necessary. Understanding and the controlling the diffusion and drift current are essential for the designing, analyzing electronic devices and circuit, as they dictate the behavior of charge carriers within material, impacting the performance of the semiconductor devices like transistor and diodes. Now, let's come to the second important point, definition of the diffusion current and their types. Diffusion current is a flow of the charge carriers like that may be possible charge carrier is the hole or electrons within a material. Due to their natural tendency, they move from the region lower to higher concentration. The movement occurs as a result of the thermal motion and concentration gradient, and it is the one and two main component of the electric circuit in a material, with the other being drift current. Next, types of diffusion current. There are several types of the diffusion current depending on the specific characteristics of the charge carriers and the material in a equation. Here some are common types are we discussed. First is the electron diffusion current. This type of diffusion current involves the movement of the electron within the material. Electron tends to diffuse from region of higher electron concentration to the region of lower electron concentration. This phenomena is the practically important in a semiconductor and plays a very important role in the operation of electronic devices like transistor. Second, hole diffusion current. In a semiconductor material, holes are vacancies. Left behind them, electrons move from one location to another location. Hole diffusion current refers to the movement of these holes in a response of concentration gradient. Holes diffusion from the region with a higher hole concentration to region with a lower hole concentration. Ion diffusion current. In some material, especially in ionic conductors like electrolytes, diffusion current can involve the movement of the ions of the electrons or holes. In this case, positively charged ions move toward the area of lower concentration, while negative charged ions move toward area of the higher concentration. And bipolar diffusion current. In some semiconductor devices, both electron and holes can be contributed to the diffusion current simultaneously. It's known as the bipolar diffusion current and often occurs in devices like bipolar transistors. Fifth is the diffusion current in a gas discharges. In that content of the gas discharge, such as in a fluorescent lamp or a gas-filled tubes, diffusion current can be referred to the movement of the charged particles. That may be possible, it's electron or other ions. Within this, the gas medium due to concentration gradient created by electric field. This type of diffusion current plays a role in a sustaining and discharge and producing light. Second was the chemical diffusion current. In the electrochemistry, diffusion current can be also referred to the movement of ions or the molecule within a solution or a electrolyte due to concentration gradients created by chemical reaction. This type of diffusion current is important in processes like electroplating and battery operation. Diffusion current is the fundamental concept in physics and electronics involving in the movement of the charge carriers within a material in a response to concentration gradient. The specific type of the diffusion current depends on the charge carriers involved and the material properties. Understanding the diffusion current is the important for the analysis and design of the electronic devices and various other physical and chemical processes. Now topic is the equation for the diffusion current. The equation for diffusion current density is given by Fink's first law of diffusion. In the context of charge carriers, that may be possible its electron or its hole in a material. This equation can be expressed as JD equal to minus D and gradient N, where JD is the diffusion current density measured in ampere per second meter. D is the diffusion coefficient of charge carriers. It's measured in a square meter per second. The diffusion coefficient characterizes how quickly charge carriers move in a response to a concentrated gradient and represent the concentration gradient of charge carriers. It is the spatial gradient of the charge carrier's concentration measured in a per cubic meter. This equation describes how the diffusion current density is proportional to the concentration of the gradient of charge carriers and inversely proportional to the diffusion coefficient. In simple terms, it tells us that diffusion current occurs when there is a difference in a charge carrier's concentration, and the magnitude of the currents depend on the how quickly charge carriers move through the material. Let's we start new topic, which is the diffusion current in a semiconductor. In this topic, we can discuss about how works diffusion current in p-n semiconductor. In a semiconductor, diffusion current refers to the flow of charge carriers. That charge carriers may be possible electron or sometimes it may be hole. Within a semiconductor material, due to differences in their concentration, it plays very crucial role in a operation of semiconductor devices like diodes and transistors. Here, the more detailed explanation of diffusion current in a semiconductor. Electron diffusion current. Let's consider we have n-top of semiconductor which has the higher concentration of the electrons as compared to holes. In this case, there is the natural tendency for the electrons to diffuse from the region of higher electron concentration to region of electron lower concentration. That means the electrons move toward the N from the p type of the semiconductor material. This electron movement constitutes electron diffusion current. Hole diffusion current in a p-type of semiconductor which has the higher concentration of the holes compared to the electrons, there is the tendency of the holes is diffused from the region of higher hole concentration, that means the p-type side, to region of the lower hole concentration n-type side. This movement of the holes constitutes hole diffusion current. Net diffusion current. In the semiconductor device, there may be both electron and hole diffusion current simultaneously participating. The net diffusion current is the algebraic sum of the electrons and hole diffusion current. It contributes to overall flow of the charge within a device and is play the very crucial role the formation of the various charge region, like a depletion region in a p injection diode. Mathematically, we also explain this. The diffusion current density for the electrons and hole in a semiconductor can be expressed using by Fick's first law. That equation we already seen previously, but here we include the concentration of the separately electrons, and we also include the concentration of the holes. For the electron, Jd is equal to minus q dE and multiply into gradient Ne. For the hole, the current density, which is equal to the q into d h and gradient of pH, where Jd denotes the current density for the electrons, q represent the charge of the electrons, that might be possible it's electron or it's the hole. dE and dH are the diffusion coefficient for the electrons and hole respectively, and gradient Ne and gradient pH are the concentration of the gradients of the electrons and hole respectively. This equation describes how electrons and hole diffusion current arises from the movement of the charge carriers. Due to concentration gradient within a semiconductor, the diffusion current is the essential factor in a semiconductor behavior and critical for the understanding the operation of semiconductor devices. Diffusion current in a Zener diode. A Zener diode is a specialized type of the semiconductor diode designed to operate in the reverse breakdown or Zener breakdown region. It exhibits a unique behavior related to diffusion current and avalanche breakdown. Here, we explain the diffusion current in a Zener diode. First is the normal operation, when Zener diode is saturated and working in a reverse bias. In typical Zener diode, it is the operated in reverse bias. This means that p-type side is the connected to the negative terminal and power supply, and n-type side is connected to the positive terminal. Under reverse bias condition, there is a small reverse saturation current that flows due to the minority charge carriers. That charge carriers that may be possible holes or a negative type of region, an electron in a p-type region, diffusing across the junction. The reverse current is often negligible in comparison to the Zener breakdown current, which is primary characteristics of Zener diode. Second one is the Zener breakdown. The distinctive feature of a Zener diode it is ability to operate in a Zener breakdown region. As the reverse bias voltage across the Zener diode increases, the electric field across the junction becomes strong enough all pull electrons from the n-type region and holes from the p-type region. This creates electron-hole pairs, and these carriers are accelerated by the strong electric field. Electrons gain energy and can collide with lattice atom in a crystal, causing additional electron-hole pairs to create a chain reaction. This avalanche effect leads to a rapid increase in a number of charge carriers, resulting in a significant increase in a current, which refer to the Zener breakdown current. The Zener breakdown current is not primarily driven by diffusion but by the avalanche multiplication of carriers due to impact ionization. While there is some diffusion current during the early stages of reverse bias, the key characteristics of Zener diode is its ability to sustain a stable reverse voltage across the diode while maintaining a constant Zener breakdown current. The behavior is crucial for the voltage regulation in an electric circuit, as Zener diode can maintain a nearly constant output voltage despite the variation in input voltage or a load conditions. Zener diode operate mostly in Zener breakdown region, where the Zener breakdown current dominates and it is driven by impact ionization rather than diffusion current. However, there is minor contribution from the diffusion current in the early stage of reverse biased. Now let's see how works diffusion current in PNP transistor. In PNP transistor, it's also known as the bipolar junction transistor. Their short form is the BJT. In BJT or a bipolar junction transistor, diffusion current plays the significant role in the operation of the devices. The PNP transistor consists with the P type of material and M type of material. The N type of material is the heavily doped material and P type is material is the lightly doped material. They are saturated like a sandwich. Here, how diffusion current works in a PN transistor. Here we discussed about how to current works in a PNP transistor. First is we are taking emitter base junction, which is the work in a forward bias. The emitter base junction is the typically forward bias, which means N-type emitter terminal is a higher voltage than the P-type is the base terminal. Due to this forward bias, electron majority charge carriers the N-type region from the emitter start diffusing into the base region, which is the area of lower electron concentration. This flow the electrons from the emitter to the base constitutes electron diffusion current, which is denoted by the IT. Second one is the base collector junction in reverse bias. The base collector junction is mainly work in reverse bias with a p-type base terminal at a higher voltage than the n-type collector terminal. The reverse bias across the base collector junction prevent the electrons from easily reaching to the collector. NPN transistor. Diffusion current in a transistor involves the movement charge carrier that may be possible, it may be electrons or a hole, across the junction due to concentration gradients. This movement of charge carriers are important for the transistor operation, especially forward bias. It's allow current of the flow through the device, while the reverse bias, it is the contracted by applied electric field, resulting a low reverse current produces. The behavior of diffusion current in transistor is the fundamental to its rectifying the electronic switching operation. So, today's lecture we summarize the diffusion current is how to produce, their types, how to play the important role in a different field like a different type of the semiconductor, just like a diode. PN junction diode is a Zener diode, is the transistor. Different type of the electronic devices have the very important characteristic which depend on the diffusion current. So, in short, we can say that diffusion current play the very crucial role to operation of the different electronic circuit in a semiconductor material or in a semiconductor field, that have the very important just because of the they use in a different kind of the fabrication like a chip. All semiconductor made by the different type of the diodes and transistor, and that produces the different kind of the chips and electronic circuits. So, it's the very important for the any device which know how to use the different diffusion current in that particular device. Thank you.